So let us solve the next numerical. In this numerical it is given that determine the constant force P that will give the system of bodies shown in figure a velocity of 3 meters per second after moving a distance of 4.5 meter from the position of rest. Coefficient of friction at all contact points is 0.2. Assume pulleys as frictionless. So in these pulley kind of numericals, there is one thing that we will assume is that now obviously in this question the force is being applied in the left direction, so all the pulleys will move in one direction itself. But in other pulley problems also, what assumption that we would do is that all pulleys, they move in only in one direction, in one fixed direction, and then after that, after the calculation based on the signs, we will ascertain that which block is actually moving in which direction, right? So here it is quite obvious that all are moving in one direction, that is towards the left, right? Now what we need to do in this is that we would, as what we had done in the previous numericals, we would draw the free body diagrams of all of them. So let us say that this is your A, this is A, this is B, and this is C, and let us draw the free body diagrams of each of them. So starting with FBD of A, and I'll just draw all the columns FBD of B and FBD of C, right? So starting with A, we have the block A. Then the movement is happening in the left direction, therefore the inertial force of this would be to the right, and the weight of this is given as 250 newtons. So the inertial force would be 250 divided by 9.81 multiplied by the acceleration. Now you see that the acceleration of all these bodies is going to be the same because all are connected through one string. So the acceleration is going to be the same. This is your force P, then there would be a tension T here, and all of them are having a coefficient of friction at all contact points is 0.2. So the weight is also acting as 250 newtons. Then there is this normal, let's say it is N1, and since the movement is happening in this direction, the friction will be like this, which is 0.2 times N1, right? So let us just apply the summation Fy and summation Fx equals to 0. So summation Fy equals to 0 will give you N1 is equal to 250 newtons. Summation Fx equals to 0 will give you what? It will give you so these three forces are acting in one direction and P is acting on the other direction. So it will give you P is equal to 250 by 9.81 A plus T plus 0.2 times 250, which is equal to 50, right? So this is one equation that we have got. We do not know the value of P, neither do we know the value of A, neither T. So there are three unknowns here, and we can hardly do anything with that. So that's fine. Okay, let us move to FBD of B. So FBD of B would be this is the block like this, right? Now this string which is going on here, this string, this will have tension same in this much portion of the string. So let us say that is the same tension T, okay, or rather let me name this as T1. This is T1, okay. So this will also be T1, okay. And on the other side of the block, we also have a tension in the string, which let us say that is T2. Now the moment of this block is like this, therefore the inertial forces would be this way, which is 100 divided by 9.81 into A. These are the inertial forces. There is now there is the weight which is acting as 100 newtons. right? So, and this is given as 4 by 3. So theta, this is your theta. Theta will be tan inverse of 4 by 3, which is 53.1301, right? So this is going to be your 100 cos theta, right? So it's your 100 cos theta, and this is going to be 100 sin theta, right? And then there is going to be this normal reaction, which is I'd say N2, and since the moment is like this, the frictional force will be 0.2 N2, like this, correct? And in these kind of numericals, you don't have to actually keep all the bodies in one coordinate system only. You can orient the coordinate system according to those objects or according to those bodies, right? So let us do the summation fy and summation fx equals to 0 for this. So summation fy equals to 0 will give me n2 is equal to 100 cos theta, which is 60 newtons. N2 is 60 newtons. So I have summation fx equals to 0. This will give me, so this one and this one all are acting in one direction, and T1 and also this one, right? We forgot the horizontal component of the weight. So 1, 2, 3 and 4, there are 4 forces acting in one direction against T1. So T1 is equal to 100 sin theta plus 0.2 into 60 plus T2 plus 100 by 9.81 into A. So again here we have around 3 unknowns, right? There are 3 unknowns here. So let me just write this as let me just further simplify this. So this is 100 sin theta is 80 plus 0.260 would be, I think, 12 plus T2 plus 100 upon 9.81, which is equal to 10.1937 times A. So this is another equation that we have got. So till now we have got 2 equations. From all of them we are not able to get something solid. Let us see what we get after drawing the FBD of C. So this is the FBD of C. Here we have the tension force T this way, and this is your T2, right? T2 is there, and now the movement is happening in this along the left, so the inertial forces will be 500 divided by 9.81 into A, this direction. And what else we have? We have the weight of it acting downwards. So weight is acting downwards, which is 500. The reaction would be your N3, I would say, and since the movement is to the left, the frictional force will be to the right, which is 0.2 times N3, right? So what are things we are going to get here? Summation Fy equals to 0. Summation Fy equals to 0 will give me N3 equals to 500 newtons, and summation Fx equals to 0 is going to give me, so there are in total these 2 forces acting against T2, so it will give me T2 is equal to 500 upon 9.81 times A plus 0.2 times N3, which is equal to 100, I guess. Yes, 100. So Fine. So we got one more equation, T2 is equal to something. Now if we find this A, somehow we'll be able to find T2, then T2 and A we can put here, we can find T1, then T1 we can put here, we can find in this equation we can find P. So what else is given? We need to determine constant force P such that all of them attain a velocity of 3 meters per second after moving a distance of 4.5 meters from the position of rest. So these three are important things that we are getting. We are getting to know that the velocity, final velocity is 3, initial velocity is 0, and the distance that they are covering is 4.5. So here we can take the help of kinematics and we can say that S is equal to ut plus half a t square, or rather we do not know the time, so we shall use that equation, v square minus u square equals to 2as. So v square we know it is 3 square minus 0 square equals to 2 into a into 4.5. Therefore a we will get from here, and a we get as 1 meters per second square. So this a now we got, we can now find T2. T2 will be how much? .9684 newtons. T2 we know, A we know, we can find T1. So T1 is how much? T1 is 253.1621 newtons. T1 we know, we can find P also now. So P we get is 328.6463 newtons, right? So this completes this numerical. Let us move on to the next numerical. So what is given in the question is, we need to determine the tension in the string and the accelerations of blocks A and B weighing 1500 Newton and 500 Newton connected by an inextensible string as shown in figure. Assume pulleys as frictionless and weightless. So this is 1500 Newton. If this moves down, we know that this 500 Newton block is going to move up. See, by logic we know this, that 1500 Newton being heavier, it is going to move down, and 500 Newton is going to move up. But as I told you in the previous numerical, that we will not assume anything here right in the beginning of the numerical, that which one is moving down or which one is moving up. We will say that let both of them move up or let both of them move down. Okay, so this is one thing that we will consider, right? So first only I'll make this assumption. Let us say both blocks move down. Okay, so when I say that both blocks move down, I am setting my sign convention right itself in this statement, that downwards is going to be positive. Okay, if you say both blocks move up, you can say that upwards can be positive. Okay, so if I get a positive value, it means that that motion is in downward direction, or that acceleration or that velocity is in downward direction. Okay, next thing what we'll do is, with respect to this fixed line, we can say that from this point to this point of the string, let us say that this is XA. Okay, XA is there. Then from this point, from the fixed point to this line, let us say it is XB, and from the fixed line to this line, it is XC. Okay, so why I am writing XA, XB and XC is because their lengths would keep on changing. XB won't change because this pulley is fixed here, okay, but still I have considered that much length. This is because I want to consider the entire length of the string, but not going around this, okay, not going around this. I just want to consider this plus this plus this, not the length which is going around the pulley. It does not matter even if you take that length. Alright, so why do I need those lengths? To write this equation that XA plus XA minus XB, XA minus XB will give me which length? This length. XA minus XB is going to give me this length. So this is XA minus XB, this is XA minus XB. Then this length is how much? What I'm actually doing here is I'm just adding all the lengths of the string to make one equation. So this length will be XC minus XB, right? So plus XC minus XB is equal to, let us say, length of the string. Okay, so even if you consider this length of the pulley, means the rope which is going around the pulley, that length is always going to be constant. That length is not going to change. So now why I'm saying that length is going to be constant, why is that important, is because now I am going to take derivative of this. I am going to take derivative of this entire this entire equation. So first of all, let me just simplify this. So it's 2 times XA minus minus 2 times XB would be there, right? So minus 2 times XB plus XC is equal to 0. L is always constant, the length of the string, no matter what, whether this moves down or up, or whether this moves down or up, the length, total length of the string will always remain constant, right? If I take derivative now of this equation, I am taking time derivative. So this is a variable distance XA, it's not going to be fixed, therefore this is not a constant, hence I need to take derivative of this, and I'll get 2 times velocity because I am taking distance with respect to time. XB is a constant. If you see, XB is constant, so its derivative is going to be 0, right? And again XC is not a constant because this length is also going to change. So minus 0 plus VA equals to 0. So we get an equation 2VA plus VA equals to 0. Again, if I take time derivative, what I'll get? 2AA plus A, this is C, right? Plus AC equals to 0. Okay, and let us say this is A and this is C. Okay, that is the reason why we have taken XA, and this is B, XA, XB and XC, right? So from this equation, what we are actually understanding is that 2AA is equal to minus AC. So the acceleration of AC is going to be, first of all, from the sign we understand that the acceleration of AC is going to be reverse of acceleration of AA. That is, if A is moving down, then C will move up. If A is moving up, then C will move down. Second thing, we understand that acceleration of C is going to be twice the acceleration of A. Okay, this is what we understand from this equation. So fine, this one equation we have set. What else? Okay, so now we can draw the FBD of A, and then we'll draw the FBD of C. So at A, FBD of A, and FBD of C. We see that this is A, and we have here two tensions T. Okay, you can see that this tension which is there, it will be same along the entire string, correct? So 2 times this tension is there here, and we have a load which is there 1500 newtons. Okay, now we will consider, now since we have already set let us say both blocks move down, therefore if the movement is downwards, what will be the inertial force? The inertial force will be upwards, which is, now this pulley is massless, it does not have any mass, so the only mass here is 1500 newton. 1500 divided by 9.81 into A, and since this is A, this has to be AA, right? See, now the acceleration is not same of both of them. We need to consider the individual acceleration here. Okay, so any other forces there? No. We'll take summation Fy equals to 0. So we'll get 2 times T plus 1500 divided by 9.81 times AA equals to 1500. This is one equation that we get here. Let us see what we get from FBD of C. So we have this block C here, which has a tension T, only one tension that way, and it has a its weight which is 500 newtons, and since we are assuming that this block is also moving downwards, therefore its inertial force will also be upwards, which is 500 divided by 9.81 into AC. Okay, so these are the forces that we have here. What do we get when we apply summation Fy equals to 0? We get T plus 500 by 9.81 times AC is equal to 500. So what we can do is we can find T in terms of this AC. So T will be equal to 500 minus 500 upon 9.81 into AC. This T we can substitute in this equation. So what we will get is, so we will get as 1000 minus 1000 upon 9.81 times AC plus 1500 upon 9.81 times AA equals to 1500, right? So the equation that we will get here is 152.9051 times AA minus 1000 divided by 9.81 is minus 101.9367 times AC is equal to 1500 minus 1000, which is 500, right? So now what we have is, we have these two equations. First is this one and the second is this one. We will solve them simultaneously to get our accelerations. So let us solve them. So we get AA equals to 1.4014 meters per second square, and since we are getting this positive, it means that this acceleration is downwards. So A is coming downwards, right, which we already knew. AC you will get as minus 2.8028 meters per second square. Since it's negative, it means it's going upwards, right? And once we found out AA and AC, we can easily find the tension. So let us find the tension. Tension T comes out to be 642.8542 newtons. Okay, so this solves this numerical. Okay, so we need to find the acceleration of the three weights as shown in figure. Assume pulleys are frictionless. Find also the tension in the cables, right? So now see what is happening here is, we are having these two pulleys. This 200 Newton is we know it is going to go down, and these two are going to go up. But here it also 60 and 40 newtons. These are also having their own acceleration. So this is going down, this is going up, right? And this whole pulley, this entire pulley is going up, this is going down. This is what we understand by logic. But we won't assume that right away. What we'll say is that, let us say all of the masses move up, Okay, so right here itself we have set our sign convention that upwards would be positive. Whatever answer we get positive, that is basically your upwards. Okay, now let us write that equation of the lengths. So let me calculate here from this fixed point. So till this point, let us say it is XA. If this I am considering as A, this I am considering as B, this I am considering as C, and this pulley also will have a variable length, because this is also changing, right? This string is also changing in its length when the movement is happening. So this is A, then let us say that till this point is XB, then till this point we have XD, in here is XC. Okay, and if you want, you can consider this as some point E, and let's say this is XE, although we know that that is not going to change, right? Now since there are two pulley systems, both of the pulleys have different means their lengths need to be equated differently, right? So for this, let's say this is the first pulley, this is the second pulley. So for pulley 1, I will say, okay, this is your first and this is second. So for pulley 1, let me write that equation. We know that XA minus XD is going to give me this length. Okay, this length plus XB minus XD is equal to length of this pulley, right? And obviously this part which is there on the pulley is this semicircular rope length, that we will not consider because that always stays constant. Hence when we take derivative of this, it is anyways going to be 0, right? Now when we take derivative of this, let me first of all write this XA minus plus XB minus 2 times XD equals to L. If I take first time derivative, I'll get VA plus VB minus 2 times VD equals to 0, and AA plus AB minus 2 times AD equals to 0. This is what I'll get, right? Then let us say for pulley 2, we can write the equation as XD minus XE, XD minus XE is going to give me this length, right? This plus XC minus XE, XC minus XE is equal to L. So this will be XD minus 2 times XE plus XC equals to L. If I take first time derivative, I'll get, and of course this XE is constant, okay? This is not a variable, it's a constant, hence this term will vanish. So VD plus VC equals to 0 and AD plus AC equals to 0, right? Now remember that we are finding the acceleration of the weights. We do not want what is the acceleration of the pulley. So here in this equation, instead of AD, I will substitute it with AC. So AD is equal to minus AC. So what I get is AA plus AB plus 2 times AC equals to 0. This is the final equation that I will be getting. Okay, of all the masses. Now this is the equation for the acceleration of all the masses. Now we just have to take the free body diagram. That's it. So starting with the FBD of A, FBD of B, FBD of C, rather C I will take at the end, and FBD of C. Okay, so A, B, D and C, this is what I am taking FBDs. So of A, let us say this is your block A, and the forces that are acting on that block means 60 Newton is there, its weight 60 Newton, then this tension I'll say T1 because this is the tension in the pulley 1. Okay, and all masses we have assumed that they move upwards. So if all masses are moving upwards, its inertial force is going to be downwards, which is 60 divided by 9.81 into AA. So this is your block A, right? Any other force is there? No other force, right? So let us say what we get by applying the summation of conditions of equilibrium. So summation Fy equals to 0, we'll get T1 equals to 60 plus 60 upon 9.81 times AA. This is what we'll get. Then FBD of B, this is my B block, which 40 newtons is the weight, T1 is the tension. This is also we are assuming it moves upwards, so its inertial forces will be downwards, which is 40 by 9.81 into AB, right? So this one also would be summation Fy equals to 0 will give me T1 equals to 40 plus 40 by 9.81 times AB. What I will do is I will put this T1 equation here. So 60 plus 60 by 9.81 times AA is equal to 40 plus 40 by 9.81 times AB. Let us rearrange the terms. So minus 40 upon 9.81 AB is equal to 40 minus 60, which is minus 20. So is equal to minus 20. This is one more equation that we have got of the acceleration. Now this obviously does not have C, acceleration of C, but that we will consider later on, because if it's not coming in this equation. So what can we do? Okay, let us say FBD of D. So we have this D, where D is a pulley. So these are your T1, your T1 and T1, and on top let us say it's T2. Okay, so this is T2. This is the only thing that we can get here, and this pulley is massless, so you can consider its inertial force. Let's say this is also moving down, this is also moving up, so its inertial force would be downwards, but since it does not have any mass, AD, let us say mass is not there, 0, so this term is anyways going to be 0. Summation Fy equals to 0, you will get 2 times T1 equals to T2. This is what you get from this FBD. Now let us move to FBD of C. So C is 200 newtons, and we only have the weight acting downwards and the tension upwards, right? So the weight of 200 acting downwards, the tension T2 acting upwards, and since this we are considering to move up, hence its inertial force will also be downwards, which is 200 upon 9.81 times AC. Yes, so summation Fy equals to 0 will yield me T2 equals to 200 plus 200 upon 9.81 times AC. Now since T2 is 2 times T1, so I can say 2 times T1 is equal to 200 plus 200 upon 9.81 times AC, and T1 I know it is 40 plus 40 upon 9.81 AB, or you can take this T1 also, which is 60 plus 60 upon 9.81 AA. Anyone you can take. So I'll take this AA1. So what it will give me is 120 plus 120 upon 9.81 times AA equals to 200 plus 200 upon 9.81 times AC. So we have an equation here, 120 upon 9.81 times AA minus 200 upon 9.81 times AC equals to 200 minus 120, which is equal to 80. Right, so this is the third equation that we got, and AB is not there in this. So there are 3 equations and 3 unknowns. When you solve all of them, you will get AA equals to 0.7954 meters per second square. This is positive, it means that it has a velocity upwards, acceleration upwards. AB you will get as 6.0981 meters per second square. This is also positive, it is upwards. AC you will get as minus 3.4467 meters per second square. This is negative, it means that it is downwards. So see, AC, we already knew that this block C is going to move downwards and both of them are going to move upwards. But if you see, AA is the least one. That is because even though both of them are moving upwards, this 60 is still moving downwards in relation to 40, and hence its acceleration decreases, right? And AB has the maximum upward acceleration. So from this you can find T1 and T2 also by substituting them. So T1, if you put AA here, you will get T1 as 64.8648 newtons, and T2 is just double of this, which is 129.7296 newtons. That's it. This completes your numerical.